Imagine a world where the boundaries of time are not fixed, where the past, present, and future are not just linear points on a timeline, but malleable dimensions that can be traversed. What if I told you that time travel is not just the stuff of science fiction, but a real, tangible possibility? What if the secrets to bending time itself are hidden within the very fabric of the universe, waiting to be unlocked? Today, we're diving deep into the mind-bending science of time travel, exploring how it's not only possible, but already happening in ways you might not even realize. Buckle up, because this journey will challenge everything you thought you knew about time. Let's start with the basics. Time travel, at its core, is about manipulating the flow of time. There are two directions you can go: forward or backward. The astonishing truth is that traveling forward in time is already happening. Yes, right now, as you watch this video, there are people hurtling through time, experiencing the future before the rest of us. How? It all comes down to speed, space, and gravity. These three forces are the keys to unlocking the mysteries of time. Take the International Space Station, for example. Floating high above Earth, the astronauts aboard the ISS are not just exploring space, they're also traveling through time. Because they're moving at incredible speeds, roughly 17,130 miles per hour, time for them passes slightly slower than it does for us on Earth. This phenomenon, known as time dilation, is a direct result of Einstein's theory of relativity. The faster you move, the slower time ticks for you, relative to someone standing still. It's a mind-blowing concept, but it's real, and it's happening right now. Consider the case of Scott and Mark Kelly, identical twins who both served as NASA astronauts. Scott spent 520 days in orbit, while Mark logged only 54 days in space. Because Scott was moving at such high speeds for a longer period, he experienced time slightly slower than his brother. The result? Scott is technically 5 milliseconds younger than Mark. That might not sound like much, but it's proof that time travel is real. Scott has, in a sense, traveled a tiny fraction of a second into the future compared to his twin. Now imagine what could happen if we could travel even faster. What if we could approach the speed of light? According to the laws of physics, time dilation becomes even more extreme at such speeds. If you were aboard a spacecraft traveling at 99.9999%, the speed of light, every second on Earth would feel like nearly 20 hours for you. Spend just one day on that ship, and when you return to Earth, 197 years would have passed. You would have effectively traveled nearly 2 centuries into the future. It's a staggering thought, and while we don't yet have the technology to achieve such speeds, the math and science suggest it's possible. But traveling forward in time is only half the story. What about going back? This is where things get really tricky and really fascinating. Traveling to the past isn't just a matter of speed, it's about bending the very fabric of space-time itself. And while it sounds like something out of a sci-fi movie, scientists have proposed several theories that could make it possible. One of the most intriguing ideas involves wormholes, hypothetical tunnels in space-time that could connect two distant points in the universe. Wormholes are like cosmic shortcuts, and if they exist, they might not just bridge space, but time as well. Imagine stepping into a wormhole and emerging in a different era. It's a thrilling concept, but there's a catch. We've never actually found a wormhole, and even if we did, we have no idea what would happen inside one. The gravitational forces could be so intense that anything entering might be crushed, torn apart, or simply vanish. Still, the possibility is tantalizing. Another theory involves something called a tipless cylinder, named after the physicist who proposed it. This theoretical time machine would consist of an infinitely long, incredibly dense cylinder spinning at billions of revolutions per minute. The rotation would warp space-time so dramatically that a spacecraft traveling along its surface could loop back in time. The catch? The cylinder would need to be infinitely long, or made of materials we don't yet understand. It's a long shot, but it's a fascinating glimpse into the kind of ingenuity required to crack the code of time travel. Then, there's the idea of creating a time machine out of space itself. Theoretical physicist Amos Ori has proposed a donut-shaped vacuum where timelines collapse in on themselves, allowing a traveler to enter at one point and exit at another time. The catch here is that you could only travel back to the moment the machine was activated, no earlier. Plus, controlling the gravitational fields to make this work would require technology far beyond our current capabilities. But the fact that such ideas are being seriously considered shows just how close we might be to unlocking the secrets of time. Of course, time travel to the past comes with its own set of challenges, namely paradoxes. The most famous of these is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born, which means you couldn't have traveled back in time to begin with. It's a mind-bending loop that has led many scientists to conclude that time travel to the past is impossible. But recent research suggests that paradoxes might not be the universe-ending disasters we once thought. Some scientists now believe that the universe has a way of self-correcting paradoxes. In the case of the grandfather paradox, the universe might simply adjust the timeline so that the man you killed wasn't actually your grandfather. Perhaps you were adopted, or your family history was different than you thought. This idea, known as the self-consistency principle, suggests that time travel to the past might be possible without destroying the fabric of reality. It's a comforting thought, but it's still just a theory. So where does this leave us? Traveling to the future is relatively straightforward. Just go really, really fast. Traveling to the past, on the other hand, requires bending the rules of space-time in ways we're only beginning to understand. It's a daunting challenge, but one that scientists are tackling with creativity and determination. And while we may not have the technology to build a time machine just yet, the fact that we're even having this conversation is a testament to the power of human curiosity and imagination. But let's not forget that, in a way, we're all time travelers. Every time you look up at the night sky, you're peering into the past. The light from stars takes years, centuries, even millennia to reach us, so what you're seeing is how those stars looked long ago. The North Star, Polaris, is 323 light-years away. When you gaze at it, you're seeing light that left the star 323 years ago. If Polaris exploded today, we wouldn't know for another 323 years. Even the moon is a time capsule of sorts. The light reflecting off its surface takes about 1.3 seconds to reach Earth. So every time you look at the moon, you're seeing it as it was a second ago. Time is a strange and beautiful thing. It's the thread that weaves the universe together, and yet it's also something we're only beginning to understand. The idea of time travel challenges us to think beyond the limits of our everyday experience. To imagine a world where the past, present, and future are not fixed, but fluid. It's a world where the impossible becomes possible, where the boundaries of reality are pushed to their limits. So the next time you look up at the stars or watch the clock tick by, remember this. Time is not just a measure of moments. It's a dimension, a force, a mystery waiting to be unraveled. And who knows? Maybe one day you'll be the one stepping into a time machine, ready to explore the past or leap into the future. The question is, would you do it? Would you take that leap into the unknown, knowing that the very fabric of reality might hang in the balance? The answer, like time itself, is yours to discover. Let's dive even deeper into the fascinating world of time travel, because the more we explore, the more astonishing it becomes. The universe is a vast, intricate web of possibilities, and the idea of moving through time is not just a dream. It's a scientific frontier that's being actively explored. So let's continue this journey and uncover even more about how time travel could work, the challenges we face, and the incredible implications it could have for humanity. Gravity, one of the fundamental forces of the universe, plays a crucial role in the possibility of time travel. According to Einstein's theory of general relativity, massive objects like planets, stars, and black holes warp the fabric of space-time. This warping doesn't just affect space, it also affects time. The stronger the gravitational field, the slower time moves. This phenomenon, known as gravitational time dilation, has been proven experimentally. For example, clocks on Earth tick slightly slower than clocks on satellites orbiting high above, where gravity is weaker. Now imagine a place where gravity is so intense that it bends time to an extreme degree. A black hole. Black holes are regions of space where gravity is so powerful that not even light can escape. If you were to approach the edge of a black hole, known as the event horizon, time would slow down dramatically for you compared to someone far away. In fact, if you could somehow orbit a black hole without being pulled in, you could experience years passing for you, while centuries or even millennia pass on Earth. It's like a natural time machine built into the very fabric of the cosmos. But black holes aren't the only gravitational phenomena that could enable time travel. Some scientists have theorized about the existence of cosmic strings, hypothetical, incredibly dense filaments of energy left over from the early universe. If two cosmic strings were to pass close to each other, they could create a loop in space-time, allowing for time travel. While cosmic strings remain purely theoretical, they offer another tantalizing glimpse into how gravity might be harnessed to manipulate time. While relativity provides a framework for understanding time travel on a cosmic scale, quantum mechanics, the study of the very small, offers its own intriguing possibilities. At the quantum level, particles don't always follow the rules we're used to. They can exist in multiple states at once, teleport across distances, and even appear to move backward in time. One of the most fascinating quantum phenomena is entanglement, where two particles become linked in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. Some researchers have speculated that entanglement could be used to send information backward in time, effectively creating a form of time travel. While this is still highly speculative, it opens up a whole new realm of possibilities for how we might one day manipulate time. Another quantum concept that could play a role in time travel is closed time-like curves, CTCs. These are paths through space-time that loop back on themselves, allowing an object or person to return to their own past. While CTCs are mathematically possible within the framework of general relativity, They require conditions that are incredibly difficult to achieve, such as negative energy or exotic matter with bizarre properties. Still, the fact that they exist as a theoretical possibility is enough to keep scientists dreaming. As exciting as the idea of time travel is, it's not without its challenges. One of the biggest hurdles is energy. To manipulate space-time in the ways required for time travel, we would need an enormous amount of energy far beyond anything we can currently generate. For example, creating a wormhole or a Tipler cylinder would require energy on the scale of a star, or even an entire galaxy. Until we find a way to harness such immense power, time travel will remain out of reach. Another challenge is the potential for paradoxes. We've already touched on the grandfather paradox, but there are countless others. What if you traveled back in time and accidentally prevented a major historical event? What if you brought something back from the future that changed the course of history? These paradoxes aren't just philosophical puzzles. They could have real, catastrophic consequences for the fabric of reality. Some scientists believe that the universe has built-in safeguards to prevent paradoxes. For example, the Novikov self-consistency principle suggests that any actions taken by a time traveler would automatically align with the existing timeline, preventing contradictions. In other words, you couldn't change the past in a way that would create a paradox, because the universe would somehow ensure that your actions were always consistent with what already happened. It's a comforting idea, but it's still just a theory. Beyond the scientific and technical challenges, time travel raises profound ethical questions. If we could travel through time, who would have the right to do so? Would it be limited to governments, scientists, or the wealthy? And what about the potential for abuse? Imagine a world where someone could go back in time and alter history for their own gain, or where entire civilizations could be erased with the push of a button. There's also the question of responsibility. If you traveled to the past and witnessed a tragedy, would you have a moral obligation to intervene? Or would you risk creating even greater harm by changing the course of history? These are questions that don't have easy answers, but they're essential to consider as we explore the possibilities of time travel. So where do we go from here? While time travel remains firmly in the realm of theory for now, scientists are making progress every day. Advances in quantum computing, gravitational wave detection, and our understanding of space-time are bringing us closer to unlocking the secrets of the universe. And who knows, maybe one day we'll discover a way to bend time to our will. In the meantime, we can take inspiration from the fact that time travel is already happening, in small but meaningful ways. Every time an astronaut orbits the Earth, every time we look at the stars, we're touching the edges of time. And every new discovery we make brings us one step closer to understanding this incredible dimension that shapes our lives. As we wrap up this journey through the science of a time travel, there's one question that remains. Would you do it? If you had the chance to travel through time, would you take it? Would you go back and relive your favorite moments, or forward to see what the future holds? The answer is deeply personal, but it's also a reminder of how precious time is. Whether or not we ever build a time machine, the time we have now is a gift, one that we should cherish and make the most of. So as you go about your day, take a moment to think about the incredible possibilities that lie ahead. The universe is full of mysteries, and time travel is one of the most exciting of all. Who knows what the future holds? Maybe one day You'll be the one stepping into a time machine, ready to explore the past, the future, and everything in between. Until then, keep dreaming, keep exploring, and keep pushing the boundaries of what's possible. The adventure is just beginning.